We are strong believers that describing infrastructure as code is the core requirement for web project right on the start. It decreases human factor, increases automation level, provides repeatable proven processes and reproducible systems. It remains the key factor for project inheritance, audit, scale, and delivery speed. We strongly discourage using of Docker Compose and would advise you to use more powerful infrastructure as code tools like Terraform. Docker Compose works well only with a few containers with a very simple setup. Docker Compose was not designed for reliability and predictability of deployments. It encourages bad habits of developers, leaving secrets in the source code or leaving database ports wide open. Problem of concurrent ports is very common if you are trying to host many projects on one machine. Every environment very often require a separate, not necessarily identical Docker Compose configuration, and many environments, especially public with SSL certificates, will require additional environment-specific scripts and manual procedures to manage them. While Docker Compose is just Docker Compose management, as the project grows, in reality it will use more and more different cloud resources, which need to be also saved in your code base somehow. At the same time, Terraform can provision, manage and orchestrate single or multiple cloud deployments of any complexity, being highly reusable and for all environments. And this is our recommendation from day one. So the bottom line is Docker and Terraform are paramount pieces of any of our infrastructure, and we don't recommend jump into auto-scaling cloud solutions like Kubernetes on the very start of the project, or jump to them at all, as I promised you to describe cost-effective solutions. So the cost-effective project will only require one unmanaged Linux server. So going ahead, I'll be sharing our exact approach to build Terraform configuration for any project that will be a source code for deployment on any environment, either a local, staging, or a real production. And our planning starts with understanding high-level structure of our modules. We see it like this, from right to left. Web users will be always bombarding our load balancer, which will distribute traffic between publicly available microservices, APIs, and static pages. To identify what Docker containers are publicly available, we include them in a separate Docker network. But in addition to this, project will have another Docker network, just for databases and internal APIs. No ports from it should be open to the host server by default. These containers will be used by our APIs, and Docker guarantees that no one from external network can access it, even if firewall is disabled. This guarantees the security from day one. We will never have database ports open accidentally, and we are also solving the problem of concurrent ports. In our perfect world, we will remain only two ports open, like HTTP and HTTPS. Everything else should be closed. Our way of thinking about Terraform plan implementation looks like the following. In our Terraform plan, we will be implementing several layers. Modules are reusable Terraform modules that can be copied from project to project without changes. Application is a single Terraform module that combines all the integration with the common logic. And workspace level modules can contain specifics for each environment where we will be deploying our application. Workspaces should contain only minor configuration differences between the environments. We are starting with configuration of the network module. This is the module that all of our future modules will be using as input. In fact, we will use that module for two things. The first one, just like the name says, it will actually create internal Docker network for us. But the second, its responsibility will be encapsulation of all common parameters of the project. This way we will have a single variable for all future modules with unique type. This is what we are introducing now. Project, workspace, environment, additional labels, etc. Terraform plans can be constructed from very different types of cloud resources, but for the purpose of the demo, the only provider that we'll be using will be Docker provider, and this is how it is configured. This file should be just copied later, as it is the same to all Terraform modules mentioning usage of any other Docker resources. At this point, our network module is ready. And now, we will prepare a module for our microservice. Docker images are kind of snapshots of virtual computers, and Docker containers are kind of instances of such computers that are already running and possibly have some modifications in their file systems. Terraform resource of Docker image is responsible for locating Docker image only, and if it is not present on a local machine, it will download it from external Docker container registry when applying Terraform plan. A Docker container resource is responsible for the actual Docker container instance. Here we are making sure it will always automatically restart, it will have common login options, and it will belong to our newly created internal network. No ports will be open. This is the way we set up labels to be defined dynamically with the local variable instead of providing direct constant value right in the resource. This is the point of growth, and we will get to extending these labels in the next video. Okay, our microservice module seems to be ready, and we can continue to introduce our application layer. Identically to previous steps, we start with defining input variables. Most of them will be forwarded to the network module. Postfix here is the string that will contain random ID of our environment. It will help us to keep environment unique, identifiable, and allows us to solve most of the conflicts for Docker container names, especially in case if we run many clusters like this on a single machine. Such random string will be actively used when we will introduce any kind of passwords to the databases or API secrets or tokens. Adding network module to our application. Here, I'm trying to figure out the correct way of passing all parameters into it. It will take me a while. Okay, the remaining part of application module is a reference to our microservice module. We are ready to configure the last Workspace layer. So far, it is just for local environment, and it is just a reference to our single application module. And production workspace so far is exact copy of a local environment. You should see visible differences only in the next video. This is how file system looks now, and what is important to know going ahead is that you always start working only in Terraform workspace folder. And to deploy, you need to run two commands, Terraform init and Terraform apply. The first one initializes providers of our modules. The second actually prepares changes to be confirmed for deployment. This makes every publish safe and predictable, especially if you care checking what it shows you. Okay, there were a few errors, and it will take me next 2 minutes to locate them. I left it at the cart so you could enjoy the process. On apply operation, Terraform plan gives a clear view of what will be modified in our resources. So we always have a possibility to check and verify if we are ready to move forward. As we can see from Docker processes, our application is deployed and running. Let's go inside container and check that our microservice is running as it should. And it does. So, mission of this video was accomplished. We've reviewed the basic principles of how to structure our Terraform plans, and in the next video we will make our microservice public so anyone with the browser could access it.